Hello dear students, in this video we are going to have some practice on calculation the binding energy. The first question says a nucleus has binding energy 336.125 million electron volt and its average binding energy is 8.6 million electron volt. Calculate the nucleon number. To calculate the nucleon number, we are going to divide the binding energy over the average binding energy. So it's going to be 336.125 over 8.6, and now we are going to find the number of nucleons, and that would be 39. So this is the nucleon number. So this element X, the mass number or the nucleon number is going to be 39, and we solved it. Let's see the next question. Next question says if the average binding energy is 6.4 million electron volt for a nucleus X which has mass number 10 and atomic 5, calculate the binding energy. Now the binding energy, we are going to multiply, we are going to see the average binding energy times the nucleon number, which is the mass. In this case is going to be 6.4 times 10 equal 64. So this is the binding energy, 64 million electron volt. We found it. So we got the average binding energy and we have the mass number, which is the nucleon number. We are going to multiply the average binding energy times the nucleon number to find the binding energy. If it asks you this to convert it to joule, because this is million electron volt, if the question tells you what is the binding energy in joule, you are going to see 64 times 10 times 1.6 times 10 to the power of negative 13 is going to give you the answer in joule. Let's go to another question here. It says a stable nucleus which has an atomic number of 8. Now the atomic number which is X, down here we have 8, and the ratio of proton to neutron is 1 to 1. It means if it has 8 protons, it has 8 neutrons. So the mass number is going to be 16. Why? Because the ratio is 1 to 1. If you have 8 proton, it will have 8 neutron. So it will be down the atomic number 8, but up it will be 16. Now it says its average binding energy is 8.14. And calculate the binding energy in million electron volt. And calculate the mass energy. The mass number, we got it. Now let's calculate the binding energy. Now we have 16 times the average binding energy, which is 8.4, and that will be, if we calculate it in the calculator, 134.4 million electron volt. This is the binding energy. Again, if it tells you what is the binding energy in joule, you are going to say 134.4 times 1.6 times 10 to the power of negative 13 to make it into joule. Let's go to another question here. It says the question, if the binding energy of a nucleus X is 187 million electron volt and its average binding energy is 13.36 million electron volt, calculate the mass number. Now the mass number, again, we solved a problem like this. We are going to see the binding energy over the average binding energy, and that would be equals 13.99. So we can say the mass number is 14. We can round it. It will be 14. This is the mass number. Let's go to another question here. It says, if the loss mass, now this is the mass defect of chlorine, is 0.088 atomic mass unit, Given the speed of light is 3 times 10 to the power of 8 meter per second, an atomic mass unit to convert it to kilogram is going to be we're going to multiply it by 1 times 1.6605 times 10 to the power of negative 27, and now it needs the binding energy. We said that if we have Einstein rule, E equal mc square. Now E, energy, must be in joule, and here the mass, which is the mass defect, must be in kilogram. Here in the question it gave it to us in atomic mass units, so we need to convert it. We are going to multiply times this number, so we are going to see E equals m, which is the mass defect, which is 0.088 times 1.6605 times 10 to the power of negative 27 times the speed of light square, which is 3 times 10 to the power of 8 square. This number you can just make it square from the beginning. 3 square is going to be 9, and 10 to the power of 8 square is going to be 16. So we are going to see times 9 times 10 to the power of 16. And now let's do it in the calculator to see how much is going to be. And that is going to be equal, it equals 13.151 times 10 to the power of negative 12. This is joule. If we want to convert this to million electron volt, for example, if we want to find the average binding energy, so how are we going to do? We are going to hit in the calculator this number, answer, over, we're going to divide it over 1.6 times 10 to the power of negative 13, and that is going to be 82.19 million electron volt. Now this number we are going to divide it over the mass number, which is 35, to find the average binding energy. So let's go to another question. Here it says, if the binding energy of helium is 4.54 times 10 to the power of negative 12, and the speed of light is 3 times 10 to the power of 8 meter per second, calculate the mass defect. Now in this question it needs the mass defect. Here we have the binding energy and we need the mass defect. Let's see, E equals mc square. E, we have it, it is here, the energy, it is given, the energy is given, so we're going to write it 4.54 times 10 to the power of negative 12. This we are going to divide it because it says equal mc square. Now to find the m, this is given, the c square, which is 9 times 10 to the power of 16, which is 3 times 10 to the power of 8. Now this, to find it, we are going to divide this number over the speed of light. So we are going to divide it times 10 to the power of 9 times 10 to the power of 16. We are going to calculate it to see what we'll get in the calculator. So we are going to put it like here. We have 4.54 times 10 to the power of negative 12, and down we are going to put here in the calculator 9 times 10 to the power of 16. That will be, if we look at it here, it is going to be equal, that will equal 5044.4 times 10 to the power of negative 32, and this is the mass defect in kilogram. This is in kilogram, the mass defect. We found it, so we'll just take the binding energy and we'll divide it over the speed of light to find the mass defect. Let's go to another question here. Let's see another question. It says a nucleus of an element X36. So here, a nucleus of element X36, the atomic number, and the neutron are 48. And the average bonding energy is 8.6 million electron volt. Calculate the nucleon number and find the bonding energy. Now first we'll calculate the nucleon number. The nucleon number here, we have protons. The protons are 36, which are here X36. Now it has 36 protons, and the neutrons are 48. These are the neutrons. So the nucleon number is going to be the proton plus the neutron. Now we're going to find the nucleon number, which is the mass number, by adding the atomic number plus the neutron number is going to give us the mass number, which will be 84. Now we got the number of nucleon. To find the binding energy, we are going to multiply the average bonding energy, which is 8.6, times the nucleon number, which is 84, and that will be times 8.6, which equals 84 times 8.6 equals 722.4 million electron volt. This is the binding energy. If it tells you what is the binding energy in joule, now the same number we are going to see answer times 1.6 times 10 to the power of negative 13, and that would be equal 115.58 times 10 to the power of negative 12. So got up to here. Now let's see here. If the average binding energy of lithium, which has 3, the atomic number is 3, and its average binding energy is 5.6, calculate the binding energy in million electron volt. This question is missing. The mass number should be 7. Now let's see here. If the mass number is 7, the nucleon number, so we are going to see here the mass number, which is 7 times 5.6 equals, directly we're going to calculate it, 7 times 5.6 equals 39.2 million electron volt. This is the binding energy in million electron volt. Let's go to another question here. It says sodium atom with a nuclear binding energy. Now we have the nuclear binding energy. Calculate the loss mass. We already did one like this, so easy. We are going to see the energy, which is 5.081 times 10 to the power of negative 11 over the speed of light, which is 9 times 10 to the power of 16. The speed of light square, which is 3 times 10 to the power of 8 square, is the same as this number, because some students do not know why I put it 9 times 10 to the power of 16. They say, where did you get it, teacher? I made it square from the beginning, because the less calculation, the less calculations, the less you can make mistakes. So I just do it like this. So let's calculate this one. We are going to see 5.81 times 10 to the power of negative 11. That would be over 9 times 10 to the power of 16, and that equals 5.6 times 10 to the power of negative 28 kilogram, sorry. Okay, now you got the binding energy in kilogram, as the question asked you. Calculate the mass defect. We got the mass defect. Now it says calculate the average binding energy. So this is the mass defect. Now let's just erase this one here from here. And let's put this one here to have a space for the next part of the question. Okay. Now, this is the loss mass. It says calculate the loss mass. We got it. It says calculate the average binding energy. Now the average binding energy, we are going to convert this, the energy, binding energy, we are going to convert it to million electron volt. So we are going to convert the energy to million electron volt. How we are going to convert it? We'll see 5.8 to the power of K over 1.6 times times 10 to the power of negative 13. Now we made it million electron volt. So the binding energy in million electron volt is going to be 317.56. Now this is the binding energy in million electron volt. This is going to be divided over 23, the nucleon number. So we're going to say answer over 23. That is going to be 13.8 million electron volt. This is the average binding energy. Let's go back to the steps. What did we do? First of all, it asks us to find the loss mass, the mass defect. We got it in kilogram. Now it asks us to calculate the average binding energy. So the binding energy, we are going to convert it to million electron volt. How? By dividing over 1.6 times 10 to the power of negative 13. It is given here in the question. They gave us 1 million electron volt equals 1.6 times 10 to the power of negative 13 to convert it to million electron volt. So we will divide to make the joule into million electron volt. We got it. This is the energy in million electron volt. Now this number, we are going to divide it over the nucleon number, which is 23, and we got it 13.8 million electron volt, the final answer. Let's go to another question here. The next question says, nucleus of uranium has an average binding energy of 7.6 million electron volt. Calculate the binding energy and find the proton number. First of all, let's find the proton number. Here it is, the proton number. Some questions in the ministry are very easy, but if a student doesn't know if the student doesn't read the question very carefully. Now, let's see here. The proton number, it is right away 92. Now, if it tells you what is the neutron number, the mass number minus the atomic number, the neutron number is going to be 238 minus 92. And that would be the neutron number 146. So, neutron, and these are the proton, 92. Now, let's see what the question says. The question says, uranium has average binding energy 7.6. Calculate the binding energy. Now, let's calculate the binding energy. The binding energy is going to be the average binding energy, average binding energy times the nucleon number. Nucleon number, in this case, going to be 7.6 times 238. Let's calculate it. 7.6 times 238. That equals 1808.8 million electron volt. If you want to convert it to joule, you are going to see answer times 1.6 times 10 to the power of negative 13. That is going to be 289.4 times 10 to the power of negative 12 joule. So we got the answer in million electron volt, and I give you one step further, which is find it in joule. If it asks you to find it in joule, this is how you do it. Let's go to next question. Here, if the nuclear bonding energy of iron equals 487.2 million electron volt, calculate the average bonding energy. Very easy. We are going to divide the binding energy over the nuclear number and find the proton number. The proton number, it is 26. It doesn't need any calculation. But let's see here. The average bonding energy, we are going to see 487.2 over 56. That equals 8.7 million electron volt. Very high nuclear bonding energy, which average bonding energy, which makes iron the most stable element. Let's go to next question. It says, if the loss mass, the mass defect of nitrogen equal 0.216 times 10 to the power of negative 27, and the speed of light is 3 times 10 to the power of 8 meter per second, calculate the nuclear bonding energy. To calculate the nuclear bonding energy, what we are going to do, let's see here. We have the loss mass. Now, energy equals mc square. Energy equals m, which is 0.216 times 10 to the power of negative 27. This times 9 times 10 to the power of 16, which is 3 times 10 to the power of 8 square. Let's do this one. So 0.216 times 10 to the power of negative 27. Okay, this is times 9 times 10 to the power of 16, 19.44 times 10 to the power of negative 12 joule. This is the binding energy. So let's go to the last question here. It says, if the average bonding energy of X, which has 9 as atomic number and 4 as mass, 9 as mass and 4 as atomic number, the average bonding energy is 7.2. Calculate the bonding energy in million electron volt and find the nuclear number. Oh, the nuclear number is 9. It doesn't need any finding. Let's go to the next part. This is just to show you how easy sometimes the question be, but sometimes the students made over calculations to make it like wrong. Let's see here. The average bonding energy is 7.2 and the nuclear number is 9, and that is going to be right away 9 times 7.2, and that is going to be 64.8 million electron volt. Got the answer, and I hope everything now is clear, and I hope you did the same calculations and you got the same answers. Until next time, ciao.